So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 354 and in this video we continue with our move assignment operator. And again here in cppreference.com we go to the language section, then down here in classes to the move assignment operator, and we have talked already about the examples here below. At least we started here the first part. And now we go on from here, and again I switch here to the compiler explorer. I change here a little bit the theme, it is darker now, and I kicked out here the assembly part so we can see it a little bit easier. Okay, now we are at line 60 and let's try to analyze this line of code. So we have here A1, which is an L value which was created here on top, and then we are putting this A1 into a statmove, which means we are converting an L value to an R value. And the reason for that is because we want to use again move semantics instead of copy, because move semantics are more performant. And remember, A1 is already created and A2 is already created as well. So we are assigning A1 to A2 and we are not creating a new object, which means not the move constructor will be called. Instead, the move assignment operator will be called. And to check what the assignment operator is doing, we have to go to the type of A2, which is of type A. So it's our class A, which is here on top. It's a struct A. And then we see here is the move assignment operator. And like all time, you can see here the parameter list is expecting again an R value, and we have converted our L value here to an R value with this statmove, so it can bind here to this parameter. And in the next line here we see that the variable name other is converted again to an R value. The question is why? Don't be irritated by the type here, which is an R value type, because other here becomes an L value because it is a named variable. So that's why they are using here again statmove to convert other then .s, which is a string from the other, to an R value, and then assigning to s. And when we go up we see s is a string, and we know a string itself can have also move semantics like constructors, this move operators and so on, and that's why they are converting all this one here so it can profit from the move semantics as well. And the next line is just for us a checkup to see if this move assignment operator is called, and we can see it here. Indeed it is called. And the next line here is just our return statement, so that the assignment operator is just returning the whole object, so we can chain if we like. So, and the other examples here down are similar to the example here, and the real difference is we have to check if the struct is fulfilling the requirements to use a move semantics or not. Okay, let's jump to line 63, and you can see now we create again two objects, b1, b2, but this time with b, and b is the struct b here, and you can see b is inheriting from a again without the word virtual, and we are using also no virtual word here in the struct. Then we can see the struct b has only two variables, so it fulfills the requirements so that the compiler can create here implicit move constructor, move assignment operator, and all the other things, and it says here already that it will be using that. Then we jump here to line 64 and we read the value s from b1, and it says here it is test because it was created here. Then we jumping to line 65, and here we see we try to assign b1 object to b2 object, and very important, it is an assignment because b1 and b2 objects were created before. And if you compare now this line here with this line, you see it is exactly the same concept. The only difference is that we have here inheritance, but this one will change nothing because it fulfills here the requirements of move semantics, and move semantics will work like here before. And keep in mind, if you use inheritance like here in struct b, you have to check the requirements not only here, you have to check the requirements also from the parents, because this can cause also problems so that it is falling back to copy assignment. In this case the requirements are met and the move assignment operator is called, and we can see this here in the next line where it says b1.s, and here is the output. It is empty, and we have talked about this already in the move constructor. It is replaced with an empty string, and whatever here was is moved now to b2. And remember, this one here is now called letting the object b1 in a valid state, which means we can still use the object b1 again, but the values are moved. And we can see this here. If we try to get access to s, we can get access to s, but we will have an empty string here, and we have to reassign it. Okay, and let's jump now to the line 69, and here we create the two objects again, C1 with C2, but this time with the struct C. Let's go top to C, and here we see that C is inheriting from B, but we have here a problem. In C we have a destructor, and we learned a destructor prevents the implicit move assignment operator, and we have not provided any move assignment operator, which means the move assignment operator will be not called. And when we go back and try to do this again, what we did before, like here and here, this time the move assignment operator will be not called, because we can see this here on the side trying to move assign C, and the copy assigned is here called. Okay, and let's jump here to the next line. This is 73, where we create again two objects, D1, D2, this time with struct D, and struct D and C are similar because they are both inheriting from B. The only difference here is we are providing here a default assignment operator, which means even if we have here a destructor, which was the problem in C, which prevented the implicit move assignment operator, with our provided default assignment operator here, we still can use move semantics, because this here, like you can read this comment here, forces a move assignment anyway. And then we try again to move D1 to D2, and we know in this case the move assignment operator will be called. It will check then B, and we know B is fulfilling the requirements as well, so it can create here also the move assignment operator, and then it will check A, and we know A has anyway here the move assignment operator defined, so it will use this one, and so it will work. And we can see this here again on our output, trying to move assigned D and move assigned cold, and this is this one which we have here. And to check the requirements here a little bit faster, there are the so-called rules of 0, 3, 5 or more nowadays, and there are different type traits. This is a code which you can write in with the struct, and it will check if the struct can use move semantics. Okay, I think that's enough for this video, and if you have any questions like all time, write in the comment section. See you next video. Bye and good luck.